Hi everyone. Today we're going to be taking a look at determining the equations of sinusoidal functions, and you're going to be coming up with the equation for both sine and cosine equations. Now, before we do that, let's just do a quick recap about what we learned about transformations of sinusoidal functions. So our general formula is y equals a sine, or it could be cos, right? Cosine. So a times sine k bracket x minus c bracket plus c, where a represents our amplitude, right? K represents our period. D represents our phase shift. And then lastly, C is our equation of the axis, right? This is when we relate it to what's happening to our sinusoidal functions, right? So A changes the amplitude, and that involves vertical stretches or compressions. K is our period, right? So that relates to our horizontal stretches and compressions. Phase shifts, that's if our graph is moving left or right? So that's horizontal translation. And then our equation of the axis, right? That's when our graph is moving up or down, so vertical translation. Okay, so in order to come up with our equation for these graphs, right, we need to determine each and every one of these things, and then basically just plug them into our equation. Okay. All right, so let's take a look at this example here. We're going to determine our sine equation first, okay? And with sine, right, remember our sine equations, we start from 0, 0, and then we go up and down and then come back, right? That's for sine. So look at your graph and then find this pattern, find this sine pattern. So it could look something like here, where that's going to start on my x-axis, right? And it's going to go up and down and then back up, right? And then that's one cycle of my sine graph, right? And that's my period. So we're going to look at that. And you're going to base it off of this cycle here to help you determine the equation. Okay, so when we look at this graph, right, let's try and solve for all of our A, K, Ds, and Cs. So we can solve for C first. C is our equation of the axis, right? Equation of axis. And we can also think of it as our vertical translations, right? So when we look at our graph, has our graph moved up or down compared to our original, right? That's my original. So it hasn't moved up or down. And in fact, it hasn't, right? My starting point, right, is on the x-axis and I end on the x-axis as well. So my C here is 0. But if you just want to double check and do your calculations, keep in mind that your C equation, you're just going to do max plus minimum divided by 2, right? So our maximum point is 2 and negative 2. So that's 2 plus negative 2 divided by 2 equals 0. Okay, so there you go. You just solved for C. We can solve for A, our amplitude, right? Amplitude is the vertical distance between your maximum to your equation of the axis, right? So if you want to solve for it, you can always do, or if you want to calculate for it, it's max minus your equation of the axis. So that's going to be 2 minus 0, which equals to 2. So you just solved for your amplitude, right? So if we think back to our original, right, if we didn't have a vertical stretch, it would look something like this, right? But our graph has been stretched vertically now, right? So our amplitude is 2. Next up, let's take a look at period. If you look back in your previous notes, right, you notice that period equals 360 over k, right? So we can just isolate for k, or if I cross multiply, so that becomes k equals 360 over the period. So we just need to look back in our graph here, our transformed graph, and determine our period. So look at your starting point, right? And that's negative 45 degrees. And then if we take a look, right, each square goes up by 45. So then this one, that's going to be 270 plus 45. 270 plus 45 is 315 degrees. Okay, so our period, right, we can do 315 minus negative 45, right? And that just equals to 360 degrees. So then to solve for k, that's going to be 360 divided by 360, which equals to 1, right? So that means our graph, there is no change in a horizontal stretch or compression, right? Okay. And then lastly, we need to solve for d. I'll just do that down here. So d is our phase shift, right? So has it moved left or right? Well, when we think about our parent function, right, it looks something like this. Oops. Right? So this is my original one. And then the transformed function, we can see that it has been moved to the left 45 degrees, right? So D would be negative 45 degrees. So therefore, right, we looked at this as a sine graph. Right? We compare this orange one to our original. I'll just make that in blue. Our original sine graph looks like that. So my transformed function then, we just solved for our C, A, K, and D. We just need to plug it in. Right? So our original one is A sine K, X minus D, bracket, bracket, plus C. So then our equation is Y equals A is 2, sine K is 1, right? You can write it or not write it, it's fine, it doesn't matter. And then X minus negative 45, so then becomes positive, so that's X plus 45 degrees, close your bracket, plus C, which is 0, so I'll just leave it out. There you go. That is your equation for our transformed sine graph. All right, now let's take a look at it and determine our equation for cosine. So same thing, right? We can think of what our original sine graph looks like, right? It's at 1 and negative 1, starts at our y-axis, and then it goes down and then up, something like that. So same thing here. We're going to look, actually, you know what might be helpful if we draw out our parent cosine function. Let's do that. So it's like this, it's going to go down and then come back up. Right, so this is my parent cosine graph. Okay, and then let's find, or let's take a look at our transformed graph and find a similar pattern to it, right? And that would be this one right here, right? Where it goes down and then back up. Okay, so let me just draw in blue like that, and then we can do orange for our parent function. Okay, So by looking at it, right, we can already see that it has been moved to the right. It definitely has been vertically stretched. Not quite sure about horizontally stretched or compressed. And we can also see that it has not been moved up or down vertically. Let's take a look at our equation for cosine. So we can solve for our equation of the axis as well, right? And like I said, it doesn't look like it's moved up or down vertically. If you want to double check, you can use our equation, max plus n divided by 2, right? Our maximum point is 2, plus our minimum point is negative 2, divided by 2, that's 0 over 2, which equals 0. Okay, so we solved for C, solve for A, our amplitude, that's maximum minus our equation of the axis. Our maximum is 2 minus our equation of the axis we just solved for, which is 0, and that's 2, right? And then let's take a look at our period, or our k value. So we know period equals 360 over k. Isolate for k. So that's k equals 360 divided by our period. Right, so let's look at our starting point. Right, so our starting point here is 45 degrees. Our end point here is, well, each box goes up by 45, so that's 360 plus 45, that's 405 degrees. Right, so our period is 405 minus 45, which equals to 360. Right, so you can just plug that in. So then that becomes 360 over 360, which is 1. Now, take a look and compare our C, A, and K value for both sine and cosine. Notice that they're the same. C equals 0 here. C also equals 0 for our cosine graph. For our sine graph, our amplitude is 2. For our cosine graph, our amplitude is also 2. For our sine graph, our k value is 1 and the period is 360. For our cosine graph, the period is also 360 and the k value is 1. Right? So there is that similarity between the sine and the cosine graph. Right? The only difference here is the horizontal translation. Right? If we compare the parent function, which was the orange graph, to our transform graph, which is blue, we can clearly see that this was our original, and then it has moved to the right at 45 degrees. Right? So then D equals positive 45 because it's been moved to the right. Okay, so solved for all of our variables, and therefore we just plug it into our equation. So this is our cosine one, right? So it's going to be y equals a cosine bracket kx minus c bracket plus c. And then we just plug it in. So a is 2, cosine k is 1, x minus 45 degrees plus c, which is 0. So we can just leave it. And that's it.